So in this video, we're going to do a nice little recap on all of the Surds required for the Year 11 Maths Advanced course. Going straight into example 1, we are trying to simplify these Surds. Now, anytime we want to simplify Surds, we want to pull out a perfect square factor. So in 108, I can pull out root 36. I can write this as root 36 multiplied by root 3. Now, root 36 is going to simplify to 6. Leaving me with 6 root 3. Remember, with Surds, we don't have to write a multiplication sign. Like with algebra, it is implied that they're multiplying. Now, we can always split up these numbers under the square root sign into a product of two numbers where one of them is a perfect square. Now, the second one is 5 times root 27. So we can split up root 27 into root 9 times root 3. Where root 9 is not a surd, right? Because 9 is a perfect square, this will simplify down to 3. So it gives me 5 times 3, which is 15 root 3. Now, last one, in 216, this is a bit of a big number. So what I'm going to do is I'm going to purposely pull out maybe the smallest perfect square factor I can think of. Now, I can break this down into root 4 times root 54. And this gives me 2 instead of root 4. Now, 54, I can see that 9 actually goes into this. 9 goes into this 6 times. So 9 is another perfect square factor I can pull out of it. So I can rewrite this as root 4 times root 9 times root 6. So even though I couldn't get the largest one out of 216 first, I can just start by pulling out one perfect square factor, this 4, and then continuing on. So root 4 times root 9 is going to give me 6 multiplied by root 6. Now, example 2, we are trying to simplify these and then collect the like terms. So in root 44, I can break this down into 2 root 11 because I can pull out 4 as a factor. Root 4 gives me 2 and then 11 is remaining. And I can pull out 9, which gives me, square root of 9 gives me 3, root 11. Then we have what we call these like surds. So root 11 and root 11, it works the same way as in algebra. I can add the coefficients, giving me 5 root 11. Now for part B, I'm going to pull out all of the perfect square factors in the exact same way. Now 36 goes into 72 2 times, that's a perfect square. So that will give me root 36, which is 6, root 2, minus, and then 25 is a perfect square that I can pull out of 50. So root 25 gives me 5, and there's a 2 remaining. And then I can pull out 4 as a factor of 12. Square root of 4 gives me 2, root 3. Now, 6 root 2 minus 5 root 2, those are like surds. So I just get 1 root 2, or root 2, plus 2 root 3. And my expression is simplified. Now, I can further go along and compute these when there's a multiplication involved. Now, when we multiply surds, we can express the product under one square root symbol. So root 15 multiplied by root 5 gives us root 75. And in 75, we can pull out 25 as a factor. So it gives me root 25 times root 3 that's left over. Now, root 25 just gives me 5. So I get 5 root 3. For the next one, just like in algebra, I can multiply the coefficients together, then I can multiply the surds together. So 5 times 7 gives us 35, root 60. Now from 60, I can split this up into root 4 times root 15. Now root 4 becomes 2. So 35 times 2 root 15, and 35 times 2 just gives us 70 root 15. Now, in the next example, we are looking at binomial expansions. So binomial expansion works in the exact same way as with algebra. So each of these terms in this bracket have to multiply with the terms in the other one. So what I'm going to get here is I'm going to get root 15 times root 3, which gives us root 45, minus 3 root 15, plus 2 root 3, minus 6. Now here I can see that 45, I can break up into root 9 times root 5, And root 9 gives me 3. So 3 root 5 minus 3 root 15 plus 2 root 3 minus 6. Now, there are no like surds I can add, but I've got this now in the most simple form because I simplified this root 45 here. Now, with the next one, we can use our identity for perfect squares. So here, anytime I have a perfect square, I can square the first term. Our middle term is going to be 2 multiplied by the product of these two plus the last term squared. Now, root 15 all squared just gives me 15, and that's minus 2 times root 15 times root 6, which gives us 90. So minus 2 root 90 plus 6. Now 15 and 6 can get added. That gives us 21 minus, and root 90 I can break up into 9 times 10. And the square root of 9 gives me 3. So 2 times 3 root 10. And this gives us 21 minus 6 root 10 in its fully simplified form. Now, last bit we're going to talk about is rationalizing the denominator. So just like the name suggests, we want the denominator to be a rational number. We don't want a surd on the bottom. Now, I can get rid of this irrational number by multiplying this surd by itself. Because if I multiply root 3 by root 3, that will give me just 3. It will remove the irrational number. And what we do to the bottom, we have to do to the top as well. So it's going to look like this. So root 7 times root 3, I should say, is root 21 over, now 2 times root 3 times root 3. When I multiply root 3 by itself, I'm just going to get 3. And this is going to equal root 21 over 6. Next one, I'm going to do the exact same thing. I have root 11 on the bottom, so I'm going to multiply it top and bottom by root 11. So on the top, I'm going to get 5 root 11. On the bottom, 55 root 11 on top of 11. And the 55 and the 11 will simplify out. That will give me 5 root 11. So I'm working with rationalizing the denominator. Now, where this gets a bit harder is where we have a binomial on the bottom. But to get this to a rational number, we want to perform a difference of 2 squares. I'm going to tell you why in a moment. But what we're going to do, in order for this to be a difference of 2 squares, I have to have these same terms, 5 and root 3, but I need a different sign to the one that's there. Now, the reason why is that when we multiply out a difference of 2 squares, we're going to get the first term squared and then the last term squared. Now, because of this difference of 2 squares, the middle terms, which would be the surd terms, will get removed. But that will leave me with a nice number when 5 is squared and a nice number when root 3 is squared. So what I'm going to get here is I'm going to get 3 outside of 5 minus root 3. These are multiplying. And 5 squared gives me 25. Root 3 squared gives me 3. So next, I'm going to expand the top. So this gives me 15 minus 3 root 3 over 22. And this can't get simplified any further. We're going to do the same thing with this other one. We're going to take those same numbers but change the sign. Because it's negative, I want to make it positive. This is going to give me a difference of 2 squares. And this will simplify out nicely. Now, 1 times this thing on the top is just going to give me 2 root 3 plus 3 root 2. And on the bottom, I'm going to have this binomial expansion that I have here. But by design, this is a difference of 2 squares. So it will tidy up very neatly. So what we're going to do is, using this difference of 2 squares, I have the same numerator, 2 root 3 plus 3 root 2. And this first term, when I square 2 root 3, that's going to give me 2 squared times root 3 squared, which gives me 4 times 3. And the second one, 3 root 2 squared, gives me 9 multiplied by 2. And once I tidy this up, on the bottom, that's going to give me negative 6. So I can just put a negative out the front. I have 2 root 3 plus 3 root 2 over 6. Now that brings us to the end of all of the Surd operations required for the Year 11 Maths Advanced course. The hardest bit is where we get to this part over here, but we just remember to rationalize the denominator. When a binomial is involved, we just need to take those same terms and change the sign so that it becomes a difference of 2 squares. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.